Hello, welcome to PhyzQuest. So this video is about some of the problems and solution of vector calculus which appear in the exam of CSIR NET from June 2011 to December 2019. So this is the first part of the video where we will discuss the problems from June 2011 to December 2012. So the first question is, vector A and vector B be the two distinct three-dimensional vectors. Then the component of vector B that is perpendicular to vector A is given by 4 options are given and we need to choose the correct option. So let's start with the solution. So here we have two three-dimensional vector A and vector B like this. Let us suppose angle between them is theta. Now the vector perpendicular to both A and B will be equal to vector A cross B. So this A cross B is perpendicular to the plane containing vector A and vector B. Now the value of this is equal to AB sin theta k cap. K cap is the unit vector perpendicular to vector A and vector B. Now here, if we take the cross product of vector A and vector A cross B, so what will happen is the resultant vector will be perpendicular to vector A, and our question is to find out the component of B which is perpendicular to A. So if we take the cross product of vector A and vector A cross B, from the resultant vector we can calculate the component of vector B which is perpendicular to A, vector A. Okay, so vector A cross B, this will be equal to AB sin theta vector A cross k cap, which is equal to minus A square B sin theta j cap. Here j cap is the unit vector of the component of vector B that is perpendicular to vector A. Now why there is a minus sign, I'll explain it. See, for that let's draw a 2D image of vector A and vector B like this. So this is vector A and vector B and angle between them is theta. So here the B cos theta is the component which is along the direction of vector A, and B sin theta is the component which is perpendicular to vector A. Now we are talking about this vector A cross B. So here the resultant vector of the cross product of vector A and vector A cross B has this direction, which is opposite to the component of vector B which is perpendicular to A. So if you have to imagine a bit, see here, this is vector A and vector A, this B. So B sin theta will be somewhere this direction, okay, and A cross B is along this direction. So they are opposite direction. Therefore there is a minus sign here. So now we can calculate it. So the component of vector B perpendicular to vector A is B sin theta j cap. So which is equal to, from this term contains B sin theta j cap. So from this we can write it down as equal to minus vector A cross B divided by A square, which is, if you omit the minus sign, the cross product order will change. So it will be vector A cross vector B cross A divided by A square, which is, if you look at the option, is option A. So option A is the correct answer here. Now let's move ahead to the second question. Second question is from the CSIR NET June 2012. So the question is, a vector perpendicular to any vector that lies on the plane defined by x plus y plus z is equal to 5 is. That's what we need to find out. 4 options are given and we need to choose the correct option. So the solution here is, in this question we have a plane whose equation is x plus y plus z minus 5 is equal to 0. Let's call it as phi, symbolize it as phi. Okay, now the question is, we need to find out a vector which is perpendicular to any vector that lies on the plane. Now here, if you understand it, which basically means we need to find out a vector which is perpendicular to the plane itself. Any vector lies on the plane or perpendicular to the plane, it's the same thing. So here, that means, as we know, the normal to any surface can be calculated by taking the gradient of the surface equation. And gradient of any function is a vector quantity. So here we need to find out the perpendicular vector to the plane. So therefore we need to take the gradient of the plane, the equation of the plane. That means gradient of phi, which is equal to I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z. Now phi is x plus y plus z minus phi. If we put the value of in this expression phi in all these differentiate terms, all the terms will be, the value of del phi by del x is 1, del phi by del y is also 1, and del phi by del z is also 1. So ultimately the answer will be here I cap plus j cap plus k cap. So this is the vector perpendicular to any vector that lies on the plane, on the given plane. Now if you check the option here, you can see that option C is matching with the result, which is the correct answer. Now let's move ahead to next question. Next question is from December 2012. So here the question is, the unit normal vector of the point a by root 3, b by root 3, c by root 3 on the surface of the ellipsoid x square by a square plus y square by b square plus z square by c square is equal to 1 is we need to calculate. So here the solution, see this question is very much similar to the previous question. Here we have the surface of an ellipsoid. So here the equation of the surface of the ellipsoid is phi is x square by a square plus y square by b square plus z square by c square is equal to 1. And here we need to find out the unit vector or unit normal vector to the surface at a particular point, which is given as a by root 3, b by root 3, c by root 3. So here now again the normal to any surface is the gradient of the surface equation, which is gradient of phi. Now the unit normal vector to any surface is, and unit vector, you know that the given vector divided by the magnitude will give you the unit normal vector. So that therefore it is gradient of phi divided by magnitude of gradient of phi. So now let's do the calculation. So here we have the surface equation as phi as this, and gradient of phi is I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z. Now if we put phi here and do the calculation, it will be I cap 2x by a square plus j cap 2y by b square plus k cap 2z by c square. So this is your gradient of phi. Now question here is, we have to find out the normal vector at a particular point, which is a by root 3, b by root 3 and c by root 3. So if we put in place of x as a by root 3, y as b by root 3 and c as z by root 3, and in place of z as c by root 3, it will be equal to gradient of phi is I cap 2 by a root 3 plus j cap 2 by b root 3 plus k cap 2 by c root 3. This is your gradient of phi. This is the normal vector. We need to find out the unit normal vector. That means we have to now divide the magnitude of the same vector. So therefore it is, now magnitude of this vector is gradient of phi magnitude will be the modulus will be equal to square root of, we have to take the sum of the square of these terms. So this will be 4 by 3a square plus 4 by 3b square plus 4 by 3c square. Now if you can take common the 4 by 3, this will be equal to 2 by root 3 square root of b square plus c square plus c square by c square a square plus a square b square divided by a square b square c square. So now this term, after getting this, now unit normal vector is gradient of phi divided by modulus of gradient of phi, or the magnitude of gradient of phi. This will be equal to this term divided by this term. So this is equal to I cap 2 by root a root 3 plus j cap 2 by b root 3 plus k cap 2 by c root 3 whole divided by 2 by root 3 square root of b square c square plus c square a square plus a square b square divided by a square b square c square. So here from the numerator and from the denominator, then in the numerator we can also take common 2 by root 3. So in denominator we have 2 by root 3, in the numerator also we can take common 2 by root 3. So if we can cancel them. So ultimately you will get this is equal to bc I cap plus c a j cap plus a b k cap divided by square root of b square c square plus c square a square plus a square b square. So this is our unit normal vector. Now we have to check the options. So these are the given option. Now if you look here carefully, none of the option is actually matching here, because here in this case numerator is matching but the denominator is different. So actually for this question none of the options is matching. So now rest of the question we will discuss in part 2 of the video.